Welcome back to Topic 5 in Unit L. Today's topic is counterweights. And when we talk about counterweights, what we're really talking about is balance. And how do things balance? Well, it helps to think about a seesaw. As you guys know, if we have a seesaw and we have two people who weigh the same, and they sit the same distance apart on the seesaw, then the seesaw will stay level. The seesaw will be balanced, right? If we have two people that are equal distance from the pivot point, the seesaw will be balanced. But as soon as we have one person that's heavier than the other person, and they stay the same distance away from the pivot point, then the heavier person will begin to slide down on the seesaw, just like we have in our top picture on the right. And the lighter person obviously will then be lifted up in the air, and the seesaw is now out of balance because the heavier person is bringing his side of the seesaw down. So how do we balance a seesaw when one person is heavier? So here we have to think about a seesaw in terms of levers. And so we know that the longer a lever arm is, the more that the force gets multiplied or magnified. So in that case, if a lighter person is going to counterbalance or be a counterweight for a heavier person, then they need to be farther away from the pivot point so that their weight and their force is magnified to balance the heavier person. So if we look at the picture down here on the right, we can see that the heavier person is indeed closer to the pivot point than the lighter person, so that the lighter person's force is magnified to counter the weight of the heavier person, and the seesaw is now back in balance. And as you guys probably know also, is that evolution has figured out this balancing act as well. Two examples that your book points out actually on page 120 are the kangaroo and the pterodactyl. The kangaroo, you can see, has a fairly large and massive tail that it uses to provide a counterweight or balance when the kangaroo leans forward to run or jump. And the pterodactyl, we're actually going to be looking at the head of the pterodactyl here. You can see that the back of the head is almost a mirror image of the beak of the pterodactyl, and that allows the pterodactyl to keep its head in a balanced position when it's flying. So the back of the head there works as a counterweight to the beak to allow the head to remain balanced. And humans, of course, have figured out counterweights and counterbalances as well. Just a few examples here, a couple from your book as well. In the top right, we have a figure skater using their right leg as a counterbalance to their torso leaning forward. And so, just to use some technical terms from your book, here the torso would be called the load, L-O-A-D, and the back leg here would be called the counterbalance. Counterbalance. So those are just some terms from your book to remember. So the weight that's being offset by the counterbalance we call the load. And in addition to our own bodies, of course, we've designed machinery and technology to take advantage of counterbalance and counterweights as well. If we look at this crane here on the bottom right, the crane can lift heavy loads on its arm due to the counterbalances on the short end of the crane. So here the load would be anything hanging from the crane, and the counterbalance would be these weights on the back end. And this allows the crane to lift very heavy objects way out on this end because there's heavy counterweights to balance it on this side. And another example that's not in your book, but that you guys are maybe familiar with, is called the boom camera, used in filmmaking. Shown down on the left here, the heavy camera can be placed a long distance from the pivot point, which is just here, and it can easily be controlled by the cameraman in the back due to these, and you can see the weights that have been placed on the short end of the boom there, and those weights, those plates, allow the camera to be counterbalanced. So here the camera would be the load, and the weights on the back would be referred to as the counterbalance. Just another example of how humans have used counterweights to make life a little bit easier. So we'll wrap up this unit, which is a fairly short unit, talking a little bit about some practical uses for your own day-to-day life on how to lift things safely. So if we look at this top picture here, we can see that if we lift a box without bending our legs at all, then your back becomes a lever. And as we know, levers magnify force. So when we use our back as a lever like this, when we try to stand back upright, we're going to be putting a lot of force on our lower backs, because this lever of our spine acts as a lever. It's going to magnify the force of this heavy box that we're lifting, and that's how people end up throwing their backs out, because you magnify the force of that box onto your lower back. So to lift properly, we have our model down here on the left showing us how you need to bend your knees. The key is to keep your back vertical and keep your back straight. So the bending doesn't come at the lower back, the bending comes in the knees, and therefore you avoid that magnification of force on your lower back. So that wraps up Unit L5. Let's go back for a quick recap of what we've covered so far. First of all, we talked about what balance means in general. We pictured a seesaw where a heavy person obviously would weigh down the seesaw, and the lighter person would be lifted in the air. And then we talked about how we might be able to balance the seesaw when one person was heavier than the other. And we talked about how seesaws really come down to the ideas of levers, where the lighter person would need to sit farther away from the pivot point so that the lighter person's force could be magnified by the lever arm of the seesaw. And then we talked about how evolution has taken advantage of this idea of counterweights and balance, such as kangaroos' tails and the back of pterodactyls' heads. And then lastly, we talked about counterbalancing and how humans have learned to counterbalance loads with counterweights. So just like a figure skater's body is counterbalanced by their leg, and the boom camera with the plates, humans take advantage of counterbalances in a number of different areas. And last but not least, let's make sure we lift with our legs and not our backs. Thanks, and make sure you come back for Unit L6, which will be moments. Thank you.